This next video covers the next few examples on forces of motion, Newton's first and second laws. And this goes into Newton's second law of motion. The force needed to accelerate a particle is equal to the product of the mass of the particle and the acceleration produced. So this whole idea that force equals mass times acceleration, or more simply we just use F equals ma. So this is now question 5 of our example sheet. Find the acceleration when a particle of mass 1.5 kilograms is acted on by a resultant force of 6 newtons. So if F equals ma, the resultant force here is 6 newtons, the mass is 1.5, we're working out the acceleration, divide by 1.5, so the acceleration would be 4 meters per second squared. Okay, we're dealing with forces in newtons here, mass in kilograms, acceleration in meters per second squared. That's number 5. So these ones we have, number 6, we've got a couple of diagrams here which kind of help us to understand what's going on as well. So I'll draw them out. You've got them kind of already written down for you. So in the first one, it says the body is accelerating as shown. So part A is accelerating to the right at 2 meters per second squared. We've kind of got a box, an object of some sort. We've got horizontal forces acting. In both directions, and we've got vertical forces acting in both directions. As well. So the object is 2 kilograms. So therefore its weight, as is indicated in the diagram, would be 2g. Newton's g is the acceleration due to gravity. We've got a force y acting upwards, opposing that. We've got a force x towards the right and a force of 4 newtons to the left. Now, seeing as this body is accelerating from left to right, it's not accelerating upwards or downwards. That means the forces acting upwards and downwards, they must be balanced. Otherwise, if one was bigger than the other, if the upwards force was bigger than the downwards one, it would be moving upwards, and vice versa. If the downward force was bigger, it would be moving downwards. But because it's moving sideways, given by this, we're accelerating from left to right, those forces must be balanced. Okay, so therefore y must equal 2g. 2g being the force going downwards, y being the unknown force going upwards. And we're going to treat g as 9.8 in these questions. Remember, you've got the notes at the start. So you should have there, you've got Newton's second law of motion, F equals ma, and the force due to gravity is known as weight, and acts vertically downwards, weight equals mass times the gravitational field strength, W equals mg. So we're going to be using that quite a lot from now on. So 2 times 9.8, so our upwards force, 2 9s are 18, so this would be 19.6. Okay, so the upwards force is 19.6, the downwards force is 19.6, they're in equilibrium, and therefore the object is neither moving up nor down. Okay, however, it is moving from left to right, because we are given this acceleration in this particular direction. And so the balance, these forces aren't going to be balanced. Okay, so our force, our resultant force to the right, and we can use this as an arrow like this. So resultant force from left to right, to calculate this, we're going to say, well, we know it's moving from left to right, so x, the force to the right, minus the force to the left, must be the mass times the acceleration, or in this case, 2 kilograms times 2. Okay, the resultant force to the right is mass times acceleration. 2 times 2 is 4, but we know that x minus 4 must give us that. So x minus 4 equals 2 times 2, which is 4. So x will be 8 newtons. And there's our 2 unknown forces in this question. If you think about the x and the 4, if you've got 8 going this way, and you've got 4 going back this way, the overall outcome of this is 4 newtons going that way. Okay, and if the overall outcome the overall resultant force is F, then that's 4 newtons. And if the mass is 2, the acceleration must be 2, and it all kind of adds up in the question here. Here's our acceleration, here's our mass. Okay, you'll get used to doing this, so don't worry just yet. More examples will help you to understand what's going on. So part B, not in red. So a similar kind of setup here. There's another force acting though, but let's get our object drawn. Excuse me, not using a ruler for that bit. And then this time we've got 20 Newton force acting downwards, as well as the 4 kilograms, which will be acting as 4g. Again, mass times acceleration. The acceleration is g, which is 9.8. And then we've got a force going upwards, which is y. And the object is accelerating this time, still 2 meters per second squared, but from right to left. Just divide that. And then we've got x and 80 newtons. So we've got x going to the right, 80 newtons going to the left. Okay, and again, the object is accelerating as shown, or the body is accelerating as shown. So let's look at our vertical forces, so our resultant force going upwards or downwards. Again, with this resultant force, we know the body is accelerating from right to left because of this. It's not accelerating upwards or downwards, so the forces going upwards must be equal to the forces going downwards. So if you look at the forces going upwards, any arrows pointing upwards, well, we've just got the y. So y must be equal to the forces going downwards, which are made up of the 4g and the 20 newtons. There's 2 forces, both acting downwards. So the y force must be the same as 4g plus 20. G is 9.8. So we can stick that in our calculators or however you want to work it out. So we should get 59.2 newtons for y, because again, it's not going up or down, it's moving from right to left, so it is going sideways. And then we can work out our resultant force to the left. So resultant force to the left, because we know it's accelerating that way. So we've got 80 newtons acting towards the left. The x is acting towards the right, so minus x, it's in the opposite direction, that's our minus sign. So we know that that must be equal to the mass times the acceleration. I wouldn't always write ma here, I'm just doing it to help to start with. And the mass is 4, and the acceleration in that direction is 2. So 80 minus x is 8, and then rearrange this, we get x is 72 newtons. So y is 59.2, x is 72. Again, if you think about the sideways movement, if we've got 80 going this way, 72 going that way, our resultant force would be 8 newtons in this direction. So if the object, our resultant force, is mass times acceleration, if the object is 4 kilograms, then our acceleration should be 2, and we know it is because we're given that in the question. That's part B. That's question 6. Question 7, the last one on this video. A body of mass 5 kilograms is pulled along a rough horizontal table by a horizontal force of magnitude 20 newtons against a constant friction force of 4 newtons. So let's get this drawn. So the ruler. So here's our floor. The body is of mass 5 kilograms. I have used a rule this time. So 5 kg. It's being pulled along a rough horizontal table by a horizontal force of 20 newtons. So the force is horizontal as well as the plane, so it's in the same direction as the plane, so it's being pulled along by a force of 20 newtons, and there's a frictional force of 4 newtons. Normally we draw friction on the floor, so here, Obviously, it's going to be acting against the direction. If you're pulling something in one way, friction's acting, it's trying to prevent you, so it's acting in the other way. So this frictional force here is 4 newtons. Given that the body is initially at rest, find the acceleration of the body and the distance travelled by the body in the first 4 seconds. So if it's being pulled along, there's some sort of acceleration in this direction. So our resultant force towards the right will be given by 20 newtons minus 4 newtons. So it's going to be 16 newtons going towards the right, and the resultant force is mass times acceleration. Mass is 5 kilograms, acceleration is A. So we can tidy it all up, divide by 5. So the body will be accelerating 3.2 meters per second towards the right. Okay, hopefully that makes sense. 20 newtons acting right. As far as we know, with only 4 newtons acting left, there might be some sort of air resistance and things like that, but we're discounting all that for now, and most of the time we will do. So that means the overall force from left to right is 16 newtons, and that will be mass times acceleration, 5 times A, which is how we get our 3.2. So this is part A. Part B, the distance travelled by the body in the first 4 seconds. Well, we're told that initially the body is at rest. So U is 0. We've got the acceleration now, which is 3.2. We've got the time, which is the first 4 seconds. And we want the distance. So now we can go back to our kinematics formula. It's moving with constant acceleration, so we can use the formula. And we want to find S. We've got U, A, and T. So S will be UT plus a half AT squared, sub in. U is 0, so that's just 0. A half is accelerating at 3.2 meters per second squared, and the time we're looking at is 4 seconds. So it should be 25.6 meters in the first 4 seconds. And then part C, if you turn over, last bit of this video, the magnitude of the normal reaction between the body and the table. So if we've got our force here, then it's 5 kilograms, so we'll have 5 G newtons acting downwards. The normal reaction is always opposite to the weight, perpendicular to the plane. The plane is horizontal, so the normal reaction force will be upwards. And again, this object is moving from left to right. It's not being moved up at all or down at all. It's staying on this plane, and therefore our reaction force, which we call R, will be equal to 5G. Okay, you could even say that R minus 5G if you wanted to. That force minus this force will give us 0 times 5. There's no acceleration of the mass of 5, so R minus 5G is 0. You can think of it like that, kind of, which is the same as thinking of it a little bit more like part A. But the foot here, for me, the forces are balanced, so R must be 5G. So R will be 5 times 9.8. So R will be 49 newtons, and that's our normal reaction force. There are 3 parts to this question. And that's to do with Newton's second law of motion. The last few questions, 8, 9, 10, we'll cover in the third video.